So in this video, I'm going to walk you through how to figure out the formula of a hydrate. Earlier in the year, we talked about what a hydrate is and how it makes a lattice structure with water trapped inside, and we could determine how much water was trapped inside. But now that we've learned how to do the mole, we can use data to figure out the exact formula for a hydrate. So here I've made a really generic formula, AB, which is our ionic compound. And if we have an ionic compound that's a hydrate, what it means is that it's going to have some number X of waters trapped inside for every formula unit of the hydrate. And that's what hydrate means. Our goal here is going to be to figure out what is X, how many waters are trapped inside. So to determine the formula of a hydrate, think about what we're doing. We're going to record the mass of the hydrate with water inside. It's always going to be a solid. And then we're going to heat it, and the heat is going to remove the water. So then we're going to be left with what's called the anhydrous salt. Anhydrous means without water, and that's going to be dry. And we're going to record the mass of it. And we're not going to put the water on the scale directly, but we're going to be able to figure out the mass of water by weighing it, recording the mass before and after heating, and the difference will be the mass of water. So then we're going to calculate, we're going to convert the grams to the moles for the salt. This guy here, the anhydrous salt, we're going to convert that from grams to moles, and then we're going to convert the mass of water from grams to moles. And then we're going to look at this ratio, and that ratio is going to give us X. So here is an example problem. We've got Epsom salt, which is magnesium sulfate, which is a hydrate. And when it's heated, the water of hydration is lost. We start out with 1.66 grams of the hydrate. And we are told that after losing all the water, the mass is now 0.824 grams, and that's the dry, anhydrous means dry, MgSO4. So to think about how to set up this problem, it's a good idea to draw ourselves some pictures or imagine what to do before we start plugging numbers in. So this is the mass of the hydrate. After heating, we record the mass of the anhydrous salt, and then the difference between these two numbers, 1.687 minus 0.824, that's going to give us the mass of water. And the data that we're going to use for our calculations is going to be the mass of the dry salt and the mass of water. So then we're going to convert each of those to the moles, and to do that we're going to need the molar mass. So I've looked that up, calculated it, and I've written it up here for each compound. So then for magnesium sulfate, we start with the mass, divide by its molar mass to get the moles. Be sure not to round this number too much. I've used 3 sig figs here. I would say 3 would be the minimum. And then we do water. So starting with the mass of water, divide by its molar mass, and that gives us the moles of water. So we have the moles of salt and the moles of water. One of them is going to be bigger. Almost always, the moles of water is going to be bigger because we have more water molecules than formula units. But regardless, we're going to divide both of them by the smaller number. So for MgSO4, it's going to be divided by itself, and that's going to give us a 1 always. And when I divide the moles of water by this number here, I'm going to get X. So when we do the math here, we get 6.99, which is very close to 7. So I know that X is 7. So the formula for the hydrate is MgSO4, and then it tells us that it is heptahydrate. So there's 7 waters trapped inside for each formula unit. So we're going to do another problem. This setup is a little bit different. In this case, instead of being given exact lab data in grams, we are given the percent data, which is a really common way to give information about hydrates. So we are told that we have a hydrate, and the hydrate is 63.94% copper sulfate and 36.06% water. So what we're going to do here is, just like we did with empirical formulas, we're going to assume that we have 100 grams of the hydrate. And that allows us to think of our data in grams. So now we're going to have 63.94 grams of copper sulfate and 36.06 grams of water. We're going to need the molar masses of both of these, so I've written those down. And then we're going to use that to convert grams to moles. So here's copper sulfate, 63.94 grams divided by its molar mass gives its moles. Make sure, again, that you have at least 3. Here I have 4 sig figs, but don't round that number too much. And then we do the water. Mass of water divided by molar mass of water gives us 2.001 moles of water. And again, moles of water is going to be bigger, so we're going to divide both of them by the smaller number to get X. So it's going to be 2.001, which is the moles of water, divided by the smaller number, and that gives us 4.99, which rounds to 5. So the formula of the hydrate is copper sulfate with 5 waters trapped inside. So X is 5 here. And if we're going to write the name of that, it would be copper 2 sulfate pentahydrate.